on some things. Does anybody have anything they'd like to talk about? General or specific, either is okay. Natalie?
Can you walk us through dropping a tangent?
Sure. Do you have a specific one in mind?
Not really. I just want to go over, kind of break down the process.
Okay. Does anybody else want a specific one in mind before I just make one up on the fly? Figure 2 birds with 1 stone is great if you can get that done. No? Okay. So I'll just make my own then. So let's say we have y equals, I don't know, -2 tangent of x over 2 minus x over 8 plus 1 or something. So first thing I'd want to do is identify the values for a, c, h, and k. In order to do that, I need to make sure that my function is in kind of that transformation form by checking if the leading coefficient on x is 1. It's not here, right? It's a half. So I'd begin by factoring. So if I factor out a 1/2, well, I don't know why I wrote an x there. That makes little sense. Try pi, you goofus. It's that fire drill got me all discombobulated. So far, so good. Okay, so my values then for a is -2, c is +2, h is positive pi over 4, and k is +1. Okay there? So I'll write my transformation map. xy goes to cx plus h, and then ay plus k. I'll copy in my key points. Again, these are things that I would provide to you, the key points. And then I'm just going to take my x's, plug them in for the x, take my y's and plug them in for the y's. So when I do that, I get -3 pi over 4. And no matter what you do to undefined, it stays undefined. And then let's see, I have -1 pi over 4. And then that becomes 3. And we have pi over 4 and 1. And we have 3 pi over 4 and -1. And 5 pi over 4 undefined. So far, so good. Oh, booger schnickles. Grab this one. All right, so negative 3 pi over 4. Well, let's start here. So each grid line I can tell is like a half a pi, right? So negative 3 pi over 4 is over here somewhere, like off the chart, really. But that's okay. I'll just kind of like sketch it in. Negative 1 pi 3 is like here. 1 pi and 1 would be like here. And 3 pi over 4 is like negative 1 is there. And then 5 pi over 4 is my asymptote there. So there's my graph. And then we'll just repeat the pattern. So we're like up here, and there, my asymptote. And then there, and I'm off the graph at that point. Does that feel okay, Natalie?
How do you discover the asymptotes?
Well, they're where the undefined things are, right? So that's that asymptote, and that is that one.
Okay.
Is that okay? You're welcome. Amy? Well, I mean, if this is a half of a half is a quarter. It's like that's 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters. Is that what you're asking?
Yeah, so like, I don't know, just confused on like where, like how you know where to start the next one that you're drawing.
Well, if I look at the pattern going on, everything is happening. Like I have something, let me use a different color. So something happened there, 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 and then there. So I'm going to put a point here, 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 here.
Okay.
You know what I'm just kind of looking with my eyes is basically what I'm doing. Because the distance between points or features, I should say, including asymptotes, is going to be the same. Right, like it's not like you're going to do like 2 units over and then like 4 units and then like 3. It's all going to be the same interval in between the features there. Does that?
Yep.
Sure. It's just about like trying to look at the problem, making it as simple as possible. You know what I mean? Who else? Amy.
On the answer page for the review packet, I was a bit confused for question 2, part A and B. Because, like, what are the reference points in those cases? Like, are they different?
No, it should be the same set of reference points.
So I was like, that might not be the response.
Same sets of reference points in either case that I used on the key.
Sorry, it was question 3, not 2.
Oh, sure. Let's look at that real quick then. Oh, question 3. Okay. Still would be the same set of reference points as they're both cosines.
When I was confused on part B, just like how you
Sure. So we'll start by figuring out the values for A, C, H, and K as it's currently written. I can do that without having to manipulate anything. Okay with that, Amy? Okay, now I'll write my map. So Cx plus H, AY plus K. And I'll write down my key points for cosine. Again, these would be given to you. And then just like last time, plug my x's into my x spot and my y's into my y spot. I get negative pi over 2, 0, and 0, negative 2, and then pi over 2, 0, and then I have pi 2 again. Is that okay? Okay. So negative 2 pi, or negative pi and then 2, I can't plot. It's like off the chart here. But if I wanted to, I guess it would be somewhere like over there. We have negative pi over 2, 0, and 0, negative 2. And then pi over 2, 0, and pi 2. And then I'll just kind of continue that pattern. So I go to the midline, minimum, midline, maximum, midline, minimum. And then I'm just going to kind of draw my graph. In from here. Is that okay? Kaylee. Sure. Lexi, are you having a different question or follow-up to something we've already been looking at? Okay. You're next, so don't let me skip you. I just wanted to check and make sure that it wasn't regarding something specific that we've done already before I jumped ahead here. Okay, so you said question, which one?
Question 6, part B.
Oh, shoot. I grabbed the wrong one. So another graphing of tangent, huh? Okay, I think this one is going to be almost the same as the one we did before. So we'll start by identifying the values for A, C, H, and K. Here I have to factor. The leading coefficient on x is 1/2, so I'll begin by factoring that out. So my A is 1, my C is 2, my H is pi, and my K is 2. Is that okay? I'll write my map. So Cx plus H, AY plus K. Write down my key points. Plug in my x's, so that's going to be 0. undefined. And then that's pi over 2 and 1. And that's going to be pi and 2. That's going to be 3 pi over 2 and 3. And that one's going to be 2 pi and undefined. So I'll go put my asymptotes in first. So I have an asymptote at 0. And I have an asymptote at 2 pi. And then we have pi over 2 and 1, pi and 2, and 3 pi over 2 and 3. That's not much extension I can do because I just have that little sliver of something and there's no real point I'd even put there. So I'll just draw a little tail of it or whatever to show the teacher that, like, hey, I know it's pointing up there, but does that feel okay? Okay. In hindsight, is a little inside the actor studio here. I put the wrong axes with the wrong problems here and I made this. I should have had the axes switched. Because the other one's kind of a pain in the butt that I think I graphed wrong because I didn't look at my axes close enough because I thought I did something I didn't. So I think I graphed like I was using the axes from B for A. Everything in A should be squished a little bit thinner even. Jack.
New question.
Oh, okay. Well, we're going to do Lexi's first, and then we'll come back and grab you. No problem. Lexi.
Can you do question 5?
What page is that?
6.
Okay, so it's one of these guys. Five, which one? B? Okay.
D.
Oh, D. Okay. So we have our midpoint at 7, 2. So since that's the midpoint, I also know the midline kind of goes right through that, right? And then it says the next extrema is at 15, negative 13. So maybe that one's like over here somewhere. Clearly that's the minimum, right? I'm going to go ahead and draw the rest of the period then. So it goes back up to the midline, does another up, another down. So that's like my one full period. Does that feel okay? So right away I know the K is 2 because it has to pass through the midline. So the y coordinate from my midline point is going to give me the value for K. You cool with that? The amplitude is the distance from an extrema to the midline. So how many units does it take to go from 2 to negative 13? 15 units, right? 2 units down to 0, and then another 13 units down to negative 13. So 2 plus 13 is 15. Feel okay there? Next, I'm going to calculate the period. So what I need to do is figure out how much of a period is the section that I have. That looks like a quarter to me, right? So like that's a midline to an extrema, extrema back to midline, midline to extrema, and then extrema back to midline. So there's 4 of those sections, and I have 1 of those, so I have 1/4 of a period. Drake?
Doesn't the amplitude more or less let's usually deal with the y value though.
Yep.
And,
So I go from 2 to negative 13.
oh. Okay, I was looking at the.
Yep. Is that okay? And the distance there, the period is a horizontal distance, so I'm looking for the distance between 7 and 15. How many units is it between 7 and 15? 8 units. Still doing good? So I can multiply both sides by 4, so I know that one period is 32 units. And I know since a period is 2 pi absolute value of c, my c is going to be, when I divide both sides by 2 pi and choose the positive value, 16 over pi. Still on board there? Okay, 3 things left to do. We have to decide whether we're going to write a sine or a cosine function. We have to determine the sign for a and then the value for h. Lexi, would you like to do sine or cosine here? Does it matter?
Not really, because you have both an extreme and a midpoint.
Very good.
But I would probably go with the sine.
Okay. That's fine with me. And you're correct, it doesn't matter here because you have both midpoints and extrema, so no big deal. Ooh, boy. So from sine, we choose the point 0, 1 from the parent function. And from the transform function, which point are we going to pair that with? 7, 2. So looking at our graph that we drew, jeepers creepers, 7, 2 is here, so it would have been max, midline, min is the type of extreme or a midpoint that we have there. You good with that? And we're always reading from left to right. Okay, so we've picked that we're doing a sine function. We can figure out the sign of a by comparing the type of midline points we have. In this case, my value for a is?
7.
You mean the value for h is 7,
Oh yeah, for a it's negative.
and a is negative 15. Excellent. And so now when we put it all together, and then I'm going to write this as the reciprocal for 1 over c. And there we go. Does that feel okay, Lexi? So the hardest part was getting the period to come out of there, right? But mostly we just did that by drawing our picture and kind of looking at what we had, right? So we just kind of used our eyes. Follow-ups to this one. Okay, Amy.
Could you just explain again how you figured out that it was a 1 period plus 8?
Okay, so see the 4 colored segments? Each of them is the same horizontal distance because they're going from midpoint to extreme on each case, right? So the piece that I have is the solid red piece, which is one of those segments, right? So the part that I have is 1/4 of the entire period.
Okay.
Does that feel okay? Sure. That's kind of what I was thinking there. And I just kind of thought about it in my head. Eric.
Can you explain why A is negative 15?
Yeah. So if I compare the two type of midpoints I have, they're opposite. Right? One is midline max and the other is max midline min. Since they're opposite kinds of midline points, that's why the A is negative.
So if they were the same, it would be positive.
Correct.
Oh.
Sergio.
Why did it? I thought when you had like these type of problems, you have to write 2 equations, one for one way and one for the other.
No. So I was just on my keys, I was including both answers because there could be more than one possible answer reasonably that you could supply. So I was just giving both of them so that there wasn't like one point is right, one point is wrong. It's just there's two answers.
Okay. So on the quiz, if I gave both, would that better?
No,
Okay.
would not. Jack.
You just answered my question.
Oh, perfect. Did you have something else that you wanted to ask about?
No, I was just gonna ask about B because you gave two answers and an answer B and I only did one. I was just gonna ask about that. You just answered.
Oh, okay. That was what you were going to ask before?
Yeah.
Perfect. That was easy. Anybody else here with questions on things? Amy.
Could you do letter J on page 2?
J from page 2. What were the directions on this again? Transformation. Oh, okay. Okay. So I'm going to start by identifying the values for A, C, H, and K. Before I can do that, though, I have to make sure my function is in that transformation form, which it's not since the leading coefficient for x is not 1. So I'll start by factoring this. So I'm going to factor off a 2/3, which means that I'm going to divide each of these by 2/3. 2/3 x divided by 2/3 is obviously just x. Pi divided by 2/3, yuck. Instead of thinking about it that way, I'm going to think about it as pi times the reciprocal, same as division, right? So pi times 3/2 is going to be just 3 pi over 2. Is that okay, Amy?
Yeah.
Okay. So my A is 5. My C is 3/2. Again, this piece is 1 over C, so C is just the reciprocal. H is negative 3 pi over 2, and K is negative 8. So the order I like to do this, I do C, A, H, K. So the first thing I do for either C and A is the reflection part. Since C is positive, there's no reflection. And since the absolute value of C is greater than 1, we have a horizontal stretch by a factor of 3/2. Since the A is positive, it gives me no reflection. And since the A is greater, absolute value of A is greater than 1, I also have a vertical stretch by a factor of 5. Since the K is negative, I'm going left, and it's going to go by the absolute value of H, so 3 pi over 2 units. And then since the K is negative, we're going down, and then absolute value of H is 8 units. Does that feel okay, Amy? So probably the worst part was like the factoring the 2/3 out,
Yeah.
where it's like arithmetic. Eek. But basically what we thought about was pi divided by 2/3 is the same thing as pi times 3/2. And you just multiply the tops and bottoms together when we multiply fractions. So try to find a way to do it in my head. You know. It's all about finding the easiest way to do it, right? So much of math is not bad if you if you see the easy way to go about doing something. Or it can be really difficult feeling if you're like, I can't, I'm going to try to grind this the hardest way possible, you know? That's the beauty there, is finding the easy way to think about it. Okay. Anybody else? Okie dokie.